Okay, so this time let's finish the comments for the tokenizer, and yeah, basically that's the plan. And after that, maybe let's try to also implement the Lexer by using ChatGPT, like make ChatGPT do the tokenization for the Lexer. So I changed the structure a bit, just added a Docker file to compile the project. And basically the idea is we'll have a folder for C and the folder for the GPT version, and we'll be able to do something like checker, then put the name of the project and what stage to check, and it will run that thing. Well, yeah, you need a make file to be able to run it, but that's the only thing. So yeah, let's see. Let's do the comments. So we just need to go in the next token function, basically. And in this one, we are gonna look for, first let's see the minus. So let's also do single line comments. So as before, if we find a single minus, then it's just a minus. But if we find two of them, so if we pick and the next character is also minus, then we want to skip the entire line. So let's see. If we find another minus, it should be here. So we found one, and then the next one is still a minus. We should have a function that skips a line, I think. Or we don't. We have skip until semi. So let's do static void skip until new line, which will be the same, but it skips until the new line character. I guess it should skip until after it. But yeah, whatever, we'll do it manually. It makes more sense like that. So we find the comment. We have to skip until new line. Then yeah, sure, we can just call directly to it because it does the skip white spaces automatically, so it doesn't matter. It skips the white spaces, and this should skip the comments that begin with two minuses. Then for the last one, the last type of comment is gonna be here. So if let me see, I think I would like to have an else here better, even though we use returns. It's more like you can see it clearly. So yeah, I was here. So if LCH is equal to a star, then that means that we have comments, and on the else case it means we have parentheses, right? Here we should ch is equal to star, and we should pick char ch is Lexer pick. Okay, so that gives us Lexer read char, just to go over it, and now we should have a function to skip the comment. So I think that shouldn't be really difficult. So let's do static void skip comment. So the idea is like in the matching parentheses problem, like that's how we try to solve it. Basically we have an opened one already, so I think the idea would be, let me see, so we read one character and then wait, if we don't read any character, then the current position would be on the star, but I mean the current position would be on parentheses. So let's leave it like I don't know if I want to do skip comment and return next token, or I want to skip those two. I think it might be easier like this. So now let's do well, there's also, if we look into the tests at test 19, we have unmatched or end of filing comment. So we have different types of errors for comments. So here maybe we want to return error type, or I mean enum error type. And when we use this thing is like if this is not equal to no error, I mean enum error equals error type t. If t is not error, then we do that, but we need to keep the position of this character, so it's the same as for strings. If we look at string, where was it? Oh, we do it, but yeah, we still keep the position, so that would be the point. So we still keep the position. Oh God, I lost it. Oh, it's here. So we should keep, we can keep it here, doesn't matter. So basically we put the position of the start, I think it's always start, and the error is error. So yeah, let's see inside of skip comment. So we are gonna need the stack. Basically, let's say it's stack, but I mean it might make sense to read chart twice and start from one, right? we start from because we already have one comment, like one parenthesis opened. So now it's something like while stack is larger than 0, right? Sure, if we find an end of file, then we need to go to errors. Where are the errors? Oh, yeah, and also I moved the enums into the lexer.h file. So we have unterminated comment. Well, that's unmatched and end of file comment. So unmatched comment. Okay. Return unterminated comment. Okay. And on the else case here, if else h is equal to parentheses, we need to look at the next one. I think pretty much it's figured it out. But we need to look at the next one. If the next one is star, then we increase the stack. I think here we need to read twice. Wait a second. Well, we might as well just read again here. So it balances it. Okay, so here we read the parentheses, right? We increase the stack. Here if we find a star and then a closing parenthesis, we have to decrease the stack and read the star. And then here we read that character. I mean, it doesn't really matter if we read it or not. But yeah, we should. And at the end, depending on if, basically if the stack is 0, it means that there was no error, and otherwise it's an unmatched. Well, else if stack is less than 0. It's an unmatched comment. But I would probably just do something like this. And yeah, if the stack is less than 0. Okay. Well, would be smarter to do it here, because that way we stop with the parsing, I guess. So if we find closing, I mean, doesn't really matter, I think, but maybe it's better to do it there. Let's go make, and let's try to go on the 19 one. I haven't implemented printing, so was it if in comment? Something like that, I think. End of file in comment. So 6.5. Yeah, the 6.5 one, it got it. Oh, yeah. Okay, I see. So the other thing we need to check is in case we find a star and then the closing parenthesis. That's also like, well, can you do that in C? Not really. So that's strange that you can do it. Anyway. So here let's say char next. Oh, ch if next is equal to this thing, then yeah. No, it should be illegal unmatched comment, although it's like, and I wonder what the position should be for that one. So 2.7, I think it's 2.5. Yeah, should be 2.5, so it's sign int position, and position should be here. So if we check again now, it's 2.5, unmatched comment, unmatched comment, and end of filing comment. Okay, so weird error. Anyway, yeah, I think that should be good. Where was the parenthesis? Here. Yeah, I was thinking about something, but I forgot it, so I guess it's not important. So let's take this stuff to 19 and let's put it here, and the test should be like this. Well, maybe we run it just to have this symbol. I think that's how it should look like. Okay, so now if we do the checker, that works, but for big we still haven't run yet the thing. I mean, it looks like it gets it pretty much. So this should be put into checker tests Lexer 17 big ref. So yeah, now we made it work for all of them. So I guess that was everything for the comments. Just adding the 2 new errors, having a skip until new line, having this basically solving a easier version of the matching parentheses, because you only have one type of opening and closing parentheses. And yeah, also this edge case of if we have a start and then a closing parenthesis, then it's an error. And then the -1. Oh, this was the the one with the star, and this was the normal one. So the base case basically, and one of the edge cases. So that's all for the tokenizer in C, I guess. Finish tokenizer in C. So yeah, now let's try to see if it's possible to make ChatGPT do the stuff. So let me python -m create a virtual environment for Python. I mean, I should have done it beforehand, but whatever. So just to have LSP, and here we should install OpenAI. I think that's pretty much the only dependency. Okay, and we're gonna need a new secret key. So let me delete this now. I mean, obviously I will delete it, but it's gonna be like a test. I mean, Lexer test. What the hell? Getting freaking captured on camera. Man, embarrassing. Really embarrassing, to be honest. So let's do it using I guess export, but first let me see how you do it in Python. So import OpenAI. Wait, from OpenAI. Pretty strange. Import OpenAI. Yeah, now it works. Okay, maybe if we go to OpenAI API docs, because here they should have examples for pip install, whatever, yeah. And I mean, we can do it with curl, but let's see. Okay, so we have this thing. Does it say where to put the key? I mean, I remember it was an environment variable, but I don't know which one. From OpenAI import OpenAI. Okay, then we need to create a client. AI. We can give it the API key. Anyway, no, doesn't really matter. So let's try to run this. Python main.py. OpenAI API key. OpenAI API key. So yeah, I mean, I will obviously delete this key, so not really big deal. Okay, so it works now. I don't really care about the streaming, so let's see. GPT-4 without streaming, let's say. Response. Okay, the response, and maybe we can print it. Do I have to? I mean, I think they changed how this works, so I think I have to buy tokens beforehand now. Well, yeah, see you when I fix this. Okay, so I actually got it to work. Anyway, it doesn't matter. So the thing would be now to create a system prompt with examples and stuff, and then in the content we provide just the file. So let's see. Let's try to make it similar to our other things. So from arg parse import argument parser. Okay, let's have an if name equals main thing. Let's create, not really with API key, but we need here like Lex, I guess. Type would be, or I mean, it's like action, right? Action store true. Type boolean default false. We need this, no, help. Yeah, whatever. We also need parser add argument. I think it was Lexer stage. I don't really remember. Lex the input file. Let's do the same. Lex the input file. Cool, see a cool compiler. So here we can put prog usage description, or like description. Prog equals cool C. And the description was a cool compiler. Anyway, so for this one we need the input. Input file. Oh, no. Input file required should be false. And then we get the args by doing parse. See, like it looks really similar to, let's do exit just for oh, they are not allowing. What? You cannot have optional positional argument? That's strange. Well, I mean, this just proves that I mean, let's go into the rabbit hole. Arg parse optional positional argument. Oh, that makes sense. So it's basically the number of arguments is like one or many, or like zero or many. And we can give it default is equal to none. But I think that's okay. And if we do help, okay, looks like our thing. Oh yeah, I mean we can do it like this in ArcParse. Try to show it like this, maybe. So okay, read file. Then we're gonna have file path, which is gonna be optional string. We need from typing stuff. And we need import sys just to read from std. Sys read standard input. Then here we open the file and we read it. I mean, yeah, it's much easier to read the file in Python. And if we still go like that, let's also do from data classes import data class and have class argument or like options, and they're gonna have that. And let's do def parse args. Yeah, what I like about Python is that it doesn't matter where you put the argument parser, it doesn't require you to give it stuff. So like the argc and argv, it just gets it for some reason. So options, we get the options, and let's read the file. So let's say something like buffer equals this thing, and we're gonna have def. Oh, I put everything inside. Doesn't really matter. So Lexer run. It's gonna take the buffer. So that's where we kind of need yeah, I mean let's just create everything inside of this function. So here we need to say if options lex, then we run the buffer and we get back the tokens, maybe like that, and we print tokens. But we print tokens like this. We always have to tokenize regardless of the options, but we only print if lex is true. Well, I think I also have, or I did not. Oh yeah, I did the output. So we also have output, which is optional string. So add argument. Oh, output type, whatever. And default could be none. Default equals none. Write file. So it's, can't we have st out, right? I mean it's just print. Content. Okay, So we have to write file, but this thing, yeah, we should have a token. So although now I'm not even sure, because maybe we want to just do str and like just for the moment we're gonna do it like this, and here we're gonna pass the buffer. Okay, and we need another message here with the role being system and the content being system prompt. And yeah, then we get this thing, we return it, and for now it doesn't really matter, we can define our system prompt here, something like this. So yeah, now we just need to manually create some tokens and stuff, present it with the available tokens and maybe the characters that are available in the language, and let's see if it's able to compile stuff, or I mean just Lex. Although yeah, hopefully it responds in the correct format. We might need to validate the tokens. What's gonna be hard, I think, it's the positions. Maybe that's a bit more difficult to get, because tokens, that's easy. So let's try to get just tokens, not the errors yet. So let's see how we can define our token class. So it's gonna be a data class token, and we are gonna need the kind. Here, sure, we are gonna need a position, but for now let's say we do not. Okay, and I mean for kind we can do from enum, import enum, and let's have one class token kind, maybe something like this, and let's try to look into include Lexer H, and let's take all of these. Right. Let's see if it, oh, now it worked yesterday, it didn't for some reason. So let's put like arrow. What if I try to make a macro? So let's do QA. So the goal is go to start, and we go to beginning. We VE copy this, find this thing, press I, go here, press A, do this, go at the end, delete this one, Q. Oh, yeah. Okay, pretty easy to get a macro. Okay, so now we have the token kind. This should be token kind. And yeah, I mean, value will be a string. I think even in this one, yeah, we still do bool literal and stuff. Checker. I was thinking, what if we take, but this is gonna be too long. So like as small examples, we're gonna take, I don't know, maybe this one. Yeah, so we have all the tokens. Would be nice if we can somehow use this class to get available tokens, let's say. Let's move this thing to the top. Can we say something like available tokens? Python iterate all enum kinds. Oh, something like this would be nice to have, yeah. Okay, so that should work then. I'm really curious. For x in does that work? Oh, that works. That works, I guess. Can we do value just to get the values? That's even better. So available tokens is equal to x.value for x in token kind. Perfect. So we get the available tokens like this. Okay. Now let's see maybe an example or something. Don't even know which would be a good example. I mean, obviously big or something like that would be a good example like this one, but I feel like it's too long for the prompt. Right. So, but this one looks too short. But like, it should be enough, I think. So let's have example 1. It's gonna be something like cool this thing. Okay. The Lexer should produce the following token. I mean, let's see ChatGPT doing it. Okay, something like that, but it should actually be like this. Maybe this is enough to like I mean, it's the same number of tokens if you use new lines or not, so it's not important. For the following code, let's say for the following code, well, let's make a template, example template. Better. Example template for the following code. Then we have that thing. The Lexer, oh yeah, the Lexer should produce the following tokens. And I think we can do something like this. And then we have example one code, and it's gonna be just a code, so just this. And example one tokens, so I think we can even put it I think we can put it on a single line because it's not really important. Okay, so we have like example template, then we have the examples themselves, and then the system prompt should be oh, hopefully this doesn't break it. So let's see. Let's do an exit here and let's try to print something like this. Oh, it looks good. Okay, so oh, actually let's do example one is equal to this thing. Yeah, that could be fine. I mean, yeah, obviously you could have a list of them and do it inside of a function, but the system prompt should be, okay, let's see what this guy wrote. Let's use something. Write a Lexer for the cool compiler programming language. Tokens from the input code. For example, under the following tokens, and here let's say give it that, some examples, and then the example, and then Please write the Lexer that can take it out. And here we have to format the available tokens. Examples, it's gonna be a list. And here let's say that we join the examples by new lines. So let's see the system prompt. And basically just using ChatGPT to create a system prompt for ChatGPT. That's good one. Anyway, we don't really say what these tokens are represented in code. But I think they might be clear enough. Let's see. So let's no longer do exit. We can just delete that. So we have the system prompt. That's good. So okay. I mean, here we can also do, it doesn't really matter. Anyway, so we have that stuff, this, and let's try it. So we are inside of the, let's go with, we need to use Lex, which file should be checker. Let's start with the first one, see if it manages to give the response for it. Well, maybe we should first print here some info. Let's show the system prompt and the buffer or something. Well, this is so cringe. Wow. This is really cringe. We need to, I mean, if you go into, I think if you go into ChatGPT and try this there, please, oh no, don't write Alexa. Please, please provide the list of tokens for the following cool code. Make sure to separate the token with white spaces and use only the, no, well, I mean, only the token counting value for the token. Like adding stuff like make sure, like only with capital letters. Okay, use only the tokens. Use only the presented format for the response. Do not add any additional information. That usually does the trick. Okay. We got something. We got something back. Let's try now for the second one. I mean, would be awesome if it gets it. Current self. No, it invented some shit. Let's say current inherits class name. Yes, it invents. Maybe we need a bigger example, but I feel like if we try the example like the big one, it might be too much. But we need some kind of example that has everything inside. Now, even if it's not correct, let's say, like maybe this thing would be enough, to be honest, for the Lexer. Yeah, I think this should be pretty much enough. I mean, even just this class, this list class could be enough. But somehow this includes everything, I think. So maybe it will get it from this. So let's see. Let's change the example code. Like maybe this is not enough. Okay, let's put something like this. And here we need to use our build mains here. And let's go until we get to the main. This stuff is... Oh my god. Like really? Oh my god, really? Then let's do -o a txt or whatever. Oh, I didn't implement that. But look who is better than Tmux and Neovim. He's able to get around stupid. Let's not discuss that. Let's not pretend that I didn't. Okay, let's put everything. Oh wow, that's... And hopefully this amount of tokens is gonna make it work, hopefully. Let's see. So now it has a lot of tokens, so it goes class A, ident X, still this crap, self-type. I mean, it should know, like ChatGPT should know about cool, so it should know that self-type is a class. Like, surely it saw. Surely it saw that. Please provide. I mean, if I put here self-type, just to show it about self-type, and here when I say what it returns, what main returns should be class name self-type, maybe this makes it work. But like the other option would be to just have for each thing here examples, like a single example for arrow, a single example for a sign, and so on. A few examples for strings and numbers. Like that would be my other idea. So I think this looks better. Yeah, but also we can try that. So let's say we have token examples maybe, but it's nice to also have the code, because that's it, that's what it's gonna get. Well, anyway, like from this thing it looks like it got it, I guess. So let's see if we don't print this stuff, and let's try to get a list of tokens now. Let's try to get a list of tokens, and basically the idea is this is the text. We have to split it by spaces to get the token values or something. But how do we parse, I guess? So it's well, I guess if it has parentheses, then we can try it. So token, I mean words, and then tokens, and then for word in words. Yeah, basically if the word is already like a token, we just do token kind, and here we, well, I mean we could try to do this. Well, let me try and see if I do Python. Jesus, my brain stopped working. So I have, let's say, ASD, and I do split split by this thing. Oh, okay. Yeah, fair enough. It should work. And then let's return the tokens. Okay, so here we take all the tokens. Let's have a function for the token show. I mean, the value could be optional, I guess. So if value is none, we just put that thing, and otherwise we put it like that. And if we try to do the tokens show, I would use this. So there we have tokens, and here we do tokens show. So now if we try this thing, it shouldn't put that. It puts it. Oh, here we should use none. Okay, so I think yeah, let's try to diff this with checker tests Lexer 02 ref. It actually gets it. So that's really nice. And what next? Yeah, I'm still thinking that giving an example for each thing here could be worth. I mean, let's see if we try something with case. What happens? I mean, it still does something. Yeah, I mean, obviously it's not really a nice idea to. Let's do cat checker tests Lexer 14. Well, we could take this stuff and I put it. No, I still don't get it. Why this crap doesn't copy when I want to copy? What's wrong with the? Yeah, so annoying. Even if I try with No, it still doesn't want to. Is it stupid? I don't know, I give up on trying to get that. Okay, so let's run again. Whatever. Easier to just rerun the ChatGPT than to... Well, the other thing I should probably do is set the temperature to 0 so that it always outputs the same thing. Oh no. Oh, I did the wrong... So how can we set some arguments on this bad boy? Where is it? Oh, Lexer run should be somewhere around here. So the temperature should be in create. It should be like arguments or something. Oh my god. Frequency. Yeah, it should be here. I see some stuff. Oh, seed. That could be good, but it's not for the model. It's for something else, I think. Max tokens could probably be something that you want to use. I don't see it. Am I blind? Temperature, yeah. I'm curious to see what the default value is for temperature. Doesn't say. And there's also top P. Oh, yeah. Well, probably, yeah, you want temperature to be... And it worked. Wow, it's amazing. Let's do temperature set to 0 because that's what makes sense for our use case. We don't want randomness. Maybe you want, because if it fails to get it, maybe you want to retry. Imagine a compiler that sometimes randomly fails. That would be insane. Good luck with debugging it. Like, oof, that's crazy. Okay, so let's have a Docker file. We also need a make file. The classical readme. So we have this stuff. We need the requirements.txt. Let's do a pip freeze, see what version of OpenAI we have. Oh, it's the same one I used like a few months ago. Amazing. Well, I think it was maybe other version. Anyway, so let's copy the Docker file from this thing. Surely there is Python Docker image. There should be a Python Docker image. We can use the latest one. So let's do Alpine. So it should be 311 Alpine. Python 3.11 Alpine. So we need to add make probably. Okay, we need to copy everything. Then we need to run pip install the requirements. We don't need a make. Make we need just for running the trash. So okay, we do pip install. I think this should be everything. Yeah, we need the environment variable, but let's do something. Let's do config.yaml, and here let's say OpenAI API key, and let's copy this one. Wow, hopefully I won't forget to delete this after I finish. So that's the secret key. Like, this is the advantage of not streaming, I guess, being able to show API keys and not care about it. Watch me not being able to delete it. Okay, so we could use pip install omega conf for what version is this? So yeah, and let me sort them because I cannot stand when the requirements are not sorted. So let's do config equals read config, and let's have another data class config, and it's gonna be OpenAI API key, and read config, let's get from omega conf. Yeah, let's read the config.yaml, and I guess hopefully this works. So yeah, maybe it would make sense to get a config here or something. Config, and here for API key we need to provide the API key. So now Lexer uses config. Okay, we might also need like config example YAML just for people that use this to know what they need to provide. Okay, and obviously let's put in git ignore config.yaml, then what else? I mean docker ignore, what is like this? Docker ignore. Let's put then, and I think that's all. Okay, and requirement says everything, so now if we run that, it should be fine. Let's go back into C and look at the, not Docker file, but the make file, because we need the run. I mean, we just need the run, I think. So let's also take this one, put it like this. I think we just need the run. Anyway, so this should be Python main.py, and then the arguments. So if we try to do make run args and give it like help. Okay, perfect. Okay, so I guess maybe we are ready to try it. let's try it on GPT like this first, and let's give it 0, 1. And this will still build it. So let's see. Interesting. Did it work? Well, in the Docker file, what do you think about copying copy requirements and then copying the entire app? Because yeah, it doesn't make sense to do it in the other way. So let's run again. Just to have it built. And if it works, it works. So my guess is, okay, so let's see again the C1. It passes everything. We don't handle errors yet, so that would be interesting to do. So funny, it gets the third one. Oh my god. Even the fourth one? That would be insane. It got it. Wow, I cannot believe it. It keeps going. Name, is ChatGPT better than... It's so good. Well. It got 14 so far. Even the 15th one? Even the 15th one. I'm not expecting to get 16, but we didn't get it. The big one? It should get it, I think. But it's really big, so... So it would be really cool if it gets it. But I cannot really... We cannot be sure about it, because I think it's like 100 lines. It doesn't know how to get the comments, so maybe that's the problem. But it got 15 tests. Like, that's really nice. Because surely it cannot get the errors. Like, it doesn't know how to write them, so there's no chance. Yeah. So it got 15 tests. Pretty decent progress. I mean, isn't it the same that we managed to do in the second day? I think so. I think, yeah, on the second day we just didn't have strings, like special characters, and the comments. Oh, but we had the last one because it was easy. That's impressive though, yes. Getting these ones. Yeah, we just need to add more stuff to the prompt. And that would be it. So just to fix the all that shouldn't do anything. And I guess clean also doesn't do anything, so make file, clean, yeah, shouldn't do anything. I think it was like this. All clean run. just to have them. So yeah, we actually managed to get 15 tests by using ChatGPT. That's really nice. Would be interesting to use these tokens and yeah, basically go into creating the AST. Like, but again, that would be like after we do it in C because it's not reliable and it's more as a meme, I guess. And then yeah, obviously getting the assembly, that would be the final thing. But yeah, maybe we just need more examples for this stuff. So let's try and see for 16 what was the problem. What did it print? So it didn't get this stuff. Well, I mean, judging by the specification of the language, it got it right though. Like this remained as it should. But yeah, like it's exactly where we were on the second day with the special characters, and I think it doesn't know about comments. So that would be one thing to add. And obviously the errors, which would require more attention. Like also adding position and stuff inside of the token, but yeah, whatever. Not really needed yet. But yeah, just calling to the OpenAI API to get tokens, I think that's really cool. Maybe just for the Lexer, the system prompt should be actually like it should contain an example. For sure, it should contain, but maybe having, well, I guess for arrow assign and stuff, it's pretty obvious how to how they look like. But maybe for string literals, like maybe string literals showing it how to convert like for example there, well, let me just do a commit for it because we are, well, we didn't change anything there. So let's see, docker ignore, git ignore, docker file. Yeah, those are the right, just docker ignore, git ignore, docker file, make file, readme, the config, the main, and the requirements. Yeah. So maybe you can see something like there are also some special cases. One. Yeah, I'm curious actually what it got for the last one because that's illegal character. Let's see. So 20 illegal character. Class. Should be able to handle illegal tokens. Yeah, like maybe that's That's one thing, like adding examples for each one. But this is not really informative for it. So the escape sequences in string literal should be handled correctly. For example, the two characters should be interpreted as a single new line character. Now, well, let's put it like this. Let's put the Lexer should also handle the escape sequences TBFR. I guess obviously. The one that we actually do, I think we should also do here. So let's look at our Lexer and where is the, I guess the strings. Okay, so here. So new lines. Well, I mean, yeah. Wait a second, how do I the two characters? Oh yeah, if we have double new line and that TB and F, TBF and TB and F. Any other escape sequence should follow the rule C becomes C for any character C. So I think this might help with special characters. Probably. Not really. Yeah, I guess it's not really that easy to do it, I guess. So yeah, but we still managed to get what was it? 15 tests passing. Yeah, the only issue is like with errors, because we haven't mentioned about errors here, and special strings, but it's like whatever. Our main goal is to do the C1, so For the next steps, we need to implement the AST, the parser, and after we are done with the parser for C, we're gonna try to do the AST also in ChatGPT maybe. And yeah, I mean, I'll also play around more with it. It's not really like, it's like a side quest, I guess. So yeah, I'll look into it, and if there is something interesting, maybe I can share it. But yeah, pretty much we managed to, yeah, like we wait, checker. We got the entire C Lexer, working on all the files. So yeah, I guess that's it for today.